Welcome back to Acids, Bases, and Salts. This is part 6 of this unit, which is our last section, and we're going to be talking about the hydrolysis of salts. So finally we get to the salts part of this unit. Let's get started. So when a salt, an ionic compound, is reacting with water, it's said to be hydrolyzed. Hydro means added to water. If the salt is the conjugate base of a weak acid, it makes a base when hydrolyzed. If it is the conjugate acid of a weak base, it makes an acid when hydrolyzed. So if the salt is a conjugate base, it will produce a base. If it is a conjugate acid, it will make an acid. Remember that spectator ions are not included in net ionic equations. So we're about to write some equations, and we're going to leave the spectator ions out. So first we're going to write the hydrolyzation reaction for the following salts. Tell whether or not these aqueous solutions are going to be acidic or basic or neutral. So let's start with KC2H3O2. Because this is a salt, all salts are strong electrolytes. All salts will completely dissolve in solution. So we're going to hydrolyze, means add it to water. And so what I see is that water, and actually I'm going to make water a little bit differently than H2O. Just for now, I'm going to call water HOH. So hopefully you see that the OH will probably go with the K, and the H will probably go with the acetate ion, so that we'll end up with KOH and HC2H3O2. But that's not quite right, because KOH is a strong base. This guy's strong, which means he will completely dissolve or completely ionize in solution. So KOH is not really KOH. KOH is really K plus OH minus. Because it is a strong base, it will not stay together in solution. Well, now that you see that, hopefully you see that the K is a spectator ion, so it's not needed. So my overall reaction is just the acetate ion plus water will make OH minus plus acetic acid. That's why this is a weak reaction, because K plus is strong, the salt itself is strong, but the acetate ion is not strong. So now, will this be acidic or basic or neutral? Notice that there's an OH there, which should tell you that this is going to be basic, or it will be a base in solution. C2H3O2 minus is the conjugate base of a weak acid, which means it makes a base in solution. So here's another, NH4Br. That's NH4 plus Br minus plus water. And so I see that the water, the H2O, will either lose a hydrogen or gain a hydrogen. And I recognize this NH4. The NH4 is the kind of thing that would give a hydrogen to water, and the Br minus is the kind of thing that would take a hydrogen from water. So it looks like we've got the same thing happening. We'll end up with NH3 when the NH4 plus loses a hydrogen to water, and we'll end up with HBr, and then we'll end up with water. But hopefully you're remembering that HBr is a strong acid. So HBr is not really HBr. HBr is really H plus Br minus. So it looks like what we've got going on here is the Br minus canceling out. So overall, and I'll write it a little bit differently to make it kind of easier to see, the NH4 will donate a hydrogen to water to make NH3 and H3O plus. Or you could just say NH4 breaks into H plus and H3. So either way you kind of want to write that. Now, acidic, basic, or neutral. Notice that there's an H plus here, which should tell you that this guy is acidic or an acid. And H4 plus is the conjugate acid of the weak base NH3. All right, Na3PO4, Na 3PO4. Remember that that 3 subscript next to the Na is only there to balance the charges, so that's just how many Nas there are. The 4 for the PO4 is the identity of phosphate, so it does stay as a subscript, but the 3 will turn into a coefficient. And water. Hopefully at this point you're looking at Na from Na3PO4 and saying this is going to be the spectator ion, because NaOH is a strong base. So really I only have PO4 minus 3 in water. So the reaction from water and PO4 minus 3, well, it can't give a hydrogen to water, so it's going to have to take a hydrogen from water, which leaves it as HPO4 minus 2. And if you take a hydrogen from water, it'll be OH minus. So now, acidic, basic, or neutral, since it's taking a hydrogen from water, this guy is a base. Last one, NH4CN. All salts completely split apart, so I'm going to write it completely separate, NH4 plus and CN minus and water. Just like before, the NH4 plus is going to give a hydrogen to the water, and just like before, the CN minus is going to take a hydrogen from water. So that we'll end up with NH3 and HCN and water. The water didn't do anything, it stayed behind. So, acidic, basic, or neutral, it looks to me like this is totally neutral because the water stayed behind. I'm not going to take this HCN and split it into H plus and CN minus like I did with the HBr earlier, because HCN is weak. So it looks neutral, but it's a trick. What we need to do is actually check out the Ka and Kb values. For NH4, the Ka, just based on the chart on the back, is 5.6 times 10 to the negative 10. For Cn minus, the Kb is 2.5 times 10 to the negative 5. So the Kb for Cn minus is larger than the Ka for NH4 plus. Kb is greater than Ka, which means the base is stronger than the acid, which means the base is going to overpower this reaction, and overall this will be a basic salt. So I just wanted to show you this chart and where I got those numbers from. The Ka for NH4 plus is 5.6 times 10 to the negative 10. The Kb for Cn minus is 2.5 times 10 to the negative 5. So since Cn minus had a greater Kb than the Ka of NH4 plus, it was overall a base. Now let's identify without writing the whole reaction. So which of the following aqueous solutions would be acidic, basic, or neutral? What you're going to do is ignore the spectator ion. And so the spectator ion is going to be the ion that comes from the strong acid or base, which means you have to memorize your strong acids and your strong bases. I'll write them here for you. Strong acids, HCl, HBr, HI, and then nitric, chloric, and sulfuric. These are your strong acids. Memorize these. And then your strong bases are group 1 or 2 with OH minus. So NaOH or CaOH2. These are your strong acids or bases. We're going to ignore the ion that comes from the strong acid or the strong base. So if we look at KBr, we see that K, that's a group 1 or 2, so that K comes from strong. We ignore it. We also see Br, which comes from HBr, so that's strong, so we ignore it. Well, if we're ignoring both the K and the Br, then overall, because it's strong, this will be neutral. Let's look at the next one. NH4C2H3O2 Notice where it cuts in half. We've got NH4 plus and C2H3O2 minus. Neither of these guys are in my strong list, so they're both weak, which means you have to look up the Ka and the Kb. So we did the Ka for NH4 plus earlier. That was 5.6 times 10 to the negative 10. And then for acetate, so C2H3O2 minus, looking at the Kb, the Kb is 5.6 times 10 to the negative 10. Hey, check that out. Those are the same number. The Ka for the weak acid and the Kb for the weak base, they're the same, which means that overall this is also neutral. When it's strong, strong, it's automatically neutral. When it's weak, weak, you're going to have to check the Ka and Kb chart to determine. All right, for the next one, NaCN. Na is group 1, so Na ignore. Cn is not part of the strong. Cn is weak. So, if you put Cn with water, it doesn't have an H to give to water, so it must be taking an H from water. And if you take an H from water, you're left with hydroxide. Hydroxide should tell you that this guy is a base. KNO2, okay, K, that's group 1, ignore it. NO2, okay, that's not on this list. NO3 is, but NO2 is not, which means NO2 is weak. So if we were going to put NO2 with water, it cannot give a hydrogen to water because it doesn't have one to give. Instead, it's going to take a hydrogen from water. If you take a hydrogen from water, you're left with OH minus. OH minus tells you this is a base. Next one's CH3NH3Cl. Notice the Cl comes from HCl, so the Cl you can ignore. All I care about is the CH3NH3. CH3NH3. All right, well, there's no places on this compound to take a hydrogen. There's nowhere to fit it. Everybody already has a full octet. So this compound cannot take a hydrogen. The only thing it can do is give a hydrogen, plus water. So if it gives a hydrogen, it'll be CH3NH2 plus. And if you give a hydrogen, you'll have H3O plus. And H3O plus should tell you acid. And finally, for our last one, Na from group 1, ignore it. I from Hi is strong, so ignore it. This guy's neutral. And really fast, let me see if I can draw out that CH3NH2. I just thought it'd be more helpful if I drew it out. CH3NH2. And that'll leave a lone pair on that nitrogen. That lone pair is the place where the hydrogen will have left from, and then that's what makes that base so it can take a hydrogen if that's the reactant in the reaction. So let's look ahead at the next problem. Calculate the pH of a 0.05 molar NaC2H3O2 solution. So I'm going to go ahead and check out the K values for NaC2H3O2. And since this is going to be NaC2H3O2. And since Na is the thing that comes from a strong, I'm going to ignore that. Oh, that's a minus. I'm only looking for the C2H3O2 minus, which means I'm ignoring these guys and looking only right here, the Kb of C2H3O2 minus. Let's put that in the problem. Kb for C2H3O2 minus is 5.6 times 10 to the negative 10. So again, we're going to cancel the Na. The Na is going to be a spectator ion because it comes from the strong base NaOH. So all I have is C2H3O2 minus and water. There is not a hydrogen to give to water. There's only a place to take a hydrogen. And if you're curious about the actual structure of that molecule where it can take a hydrogen, it's going to take a hydrogen on one of these lone pairs for oxygen. So maybe right here it'll take a hydrogen or something. So there's places on that oxygen so it can take a hydrogen, so the oxygen will be happy and have a low formal charge. But either way, that's what it's going to do. So let's write that reaction. If you take a hydrogen from water, the acetate ion will be left as HC2H3O2, and water will be left as OH minus. So this is a 0.05 molar solution, and we have to find the pH. What's good now is that this turns into every other weak acid, weak base, polyprotic acid problem that we've seen. It's just an equilibrium problem. 0.05 is going to lose X. These guys are each going to gain X. Now we have K. This will be Kb because of the OH minus. And that's HC2H3O2 times OH minus divided by C2H3O2 minus. And off the chart, that was 5.6 times 10 to the negative 10 is equal to X squared divided by, hoping this approximation will be valid, 0.05. And when I cross multiply and take the square root of both sides, I get X is equal to 5.3 times 10 to the negative 6. Now again, please do not take my word for this answer. Check it on your own in your own calculator. Not only to make sure that you know how to type it in and you know how to get the answer, but also to make sure that I didn't mess up when I was getting mine, because I mess up. So make sure you got 5.3 times 10 to the negative 6. So now I'm going to take that X, which is equal to HC2, H3O2, and OH minus. If I take the negative log of that, I'm going to get 5.27. Since this was OH minus, this is going to be equal to the POH, not the pH. So pH is 14 minus POH. So pH would be 8.72. And by the way, if you're checking the contribution of X, it is 0.01%, so X was negligible. All right, let's look at the next problem. It's asking about KF. So what we need to know is for KF, K comes from the strong base KOH, completely ignore it. F comes from a weak acid, so F is the thing that we're interested in. So let's find F. F minus is 1.4 times 10 to the negative 11. Notice that this is a base. Notice that this is Kb. Kb for F minus is equal to 1.4 times 10 to the negative 11. All right, from now, work this problem on your own. Pause the video now and try it by yourself. All right, hopefully you did that. Let's write out the reaction. F minus plus water, completely ignoring the K because the K comes from the strong base KOH. F cannot give a hydrogen, so it has to take a hydrogen. If you take a hydrogen from water, you get OH minus, and also that's why it's Kb. We have 0.1 minus X, approximately equal to 0.1, and then we have X and X. So Kb is equal to HF minus, oh, sorry, HF is not minus, it's just HF, times OH minus, divided by F minus. So that's 1.4 times 10 to the negative 11 is equal to X squared divided by 0.1. Cross multiply and take the square root. X is equal to 1.18 times 10 to the negative 6, which is HF, and also OH minus. So when you take the negative log of 1.18 times 10 to the negative 6, and you get 5.9, that'll be your POH, not your pH. So pH is 14 minus 5.9. which gives you 8.1. Check yourself, check your answers, see if you got the same thing that I did. All right, last problem. This one's asking about NH4Cl. So looking at Cl, that comes from the strong acid HCl. Ignore it completely, as if it didn't exist. You're interested only in NH4, specifically NH4+. So NH4+, there it is, NH4+. It is an acid. It's got a Ka of 5.6 times 10 to the negative 10. Ka for NH4+, 5.6 times 10 to the negative 10. So we have NH4 plus water. NH4 will not take a hydrogen from water. Instead, it will give a hydrogen to water. So it becomes NH3. And when you give a hydrogen to water, water makes H3O+. We have 0.1 minus X, approximately equal to 0.1. X and X. We have Ka this time instead of Kb. That's NH3 times H3O plus divided by NH4 plus. Pause now, do the math by yourself, and then come back and let's see if we get the same answer. Alright, hopefully you did it. 5.6 times 10 to the negative 10 is equal to x squared divided by 0.1. Cross multiply, take the square root. X is equal to 7.5 times 10 to the negative 6, which is NH3, and it is also H3O plus. So when I take the negative log of 7.5 times 10 to the negative 6, and I get 5.1. Because this guy is H3O plus, that's already an acid. So that answer is already my pH. I do not have to subtract it from 14. NH4Cl is an acidic salt. And notice that it has a pH less than 7, which kind of fits in with an acid. Alright, that's hydrolysis of salts, and that's the acids, bases, and salts unit. I hope you had fun. Join me next time.